If you look on the plugs of your electrical devices, you should find labels from the manufacturers which tell you what the product is designed to handle. For example, this laptop charger tells us that for the device to work, it needs an input of between 100 and 240 volts and 1.5 amps of AC or alternating current, which is represented by this symbol here. The charger will then convert this to give an output of around 19.5 volts and 3.33 amps of DC or direct current, which is represented by this symbol. AC and DC are different types of electricity. The plugs in your homes provide AC or alternating current. In this type, the electrons do not flow in a continuous loop. Instead, they alternate between moving forwards and backwards, just like the tide of the sea. Your electrical devices, like laptops and mobile phones, will use DC electricity. In this type, the electrons flow in one direction only, directly from one terminal to the other. You can think of this like the flow of water down a river. In most cases, we transport electricity from a power station to the towns and cities using AC electricity, because it's easy to increase and decrease the voltage using transformers. And it's also very efficient to transport electricity over long distances using this method. However, there are a few high voltage DC transmission lines being used, but we won't go too much into detail on those. We mostly use DC direct current for the circuit boards of small electronic devices like laptops, mobile phones, and TVs. That's because DC is easier to control and allows circuits to be smaller and more compact. Many appliances will use a combination of AC and DC. For example, a washing machine will use AC for the induction motor, which is used to spin the tub with the clothes in. But the circuit board, which controls the settings, the lights, the timers, as well as how fast the motor spins, will use DC power. We can convert AC to DC using a device known as a rectifier. This is extremely common in electronics. We can also convert DC to AC using an inverter, and this is used, for example, with solar power systems. We have covered power inverters in great detail previously. Do check that out, links can be found in the video description down below. Okay, that's it for this video, but if you want to continue your learning about electricity and electrical engineering, then check out one of the videos on screen now, and I'll catch you there for the next lesson. Don't forget to follow us on Facebook, Twitter, LinkedIn, Instagram, as well as theengineeringmindset.com.